Okay, so let's look at this idea of the vertex and how we write these things. So this is the standard form, and this is the form that you often see for quadratics. Now, we often think of the vertex, that high point or low point, as having arbitrary coordinates h, comma, k. In the same way that we usually use x, y when we talk about graphing, for whatever reason, the convention is that we always use the letters h to be the x variable and k to be the y variable for the vertex. Okay, so the vertex of any parabola we call arbitrarily hk. Now, if you're given standard form, okay, figuring out where that vertex is a little tough. Okay, and this is how we do it. Okay, using the a, the b, and the c here. Okay, we find h by taking negative this number divided by 2 times this number. That will give us the h value, okay, the x value for the vertex. K is a little easier in that once we've found h, we plug h back into our equation to find k. And that will tell us where the vertex of the parabola is. So that'll be a lot easier to help us graph. Now there's another form of a parabola, and it's called vertex form. Now this is just what it sounds like. It's a form where it's easier to see the vertex. Okay, standard form, it's hard to see the vertex. You can find it, but it's hard to see it. Vertex form, where it's easy to see the vertex, we have the exact same a here as we did in the standard form, so that number is going to be the same. But then the form says the vertex is at h, comma k, and it's right there. If we go back to the previous example, notice this is now in vertex form. The vertex is at the point 1, comma 2. Okay, so in this case, h is 1, k is 2. Okay, and then here's a little bit of a guide. Okay, and what we're saying is that if the absolute value, what that means is if the number is between is bigger than positive 1 or less than negative 1, it makes the thing taller. Okay, it's pulling like taffy, taller. If the number is small, like a negative fraction or a positive fraction, like negative 1/2, for instance, like we saw before, what happens is the graph will get wider. So these are actually backwards. Okay, so these are narrower and wider. Okay, so compressing makes things wider. Pulling makes things skinnier. Okay. Okay. So let's look at these here. I'm going to pull up the screen shade and go one step by step. So we're looking at this equation on the left. I'm going to ask you to try to do this one on your own, which I think you can do. If somebody gives you a graph, an equation in vertex form, sometimes you want it in standard form because standard form is really nice for some things. So let's take a look at this. This is a parabola. Okay, it's negative, so that means that the parabola goes down. Okay, it's 2, which means it's a little bit skinnier, a little bit taller than the usual parabola, and the vertex is at negative 1, comma 3. So that's what we know from vertex form. That's really nice. I'm going to try to convert that to standard form, which means I'm going to try to multiply everything out and combine like terms. So here's what we do. Okay, first things first, we FOIL out this binomial. Okay, so I'm going to get negative 2 times x plus 1 times x plus 1 plus 3 out on the outside. Don't forget about that. X plus 1 squared is x squared plus 2x plus 1. That's still times a negative 2 plus 3. Lo and behold, we get negative 2x squared minus 4x minus 2 plus 3, which is negative 2x squared plus 4x, sorry, minus 4x plus 1. So these are the same quadratic function. They're the same shape. Okay, they just look different. Okay, and depending on your context, sometimes this is easier to deal with, and sometimes this is easier to deal with. We're finding so far that this, the vertex form, is way easier to deal with if you're trying to graph it. Okay, so I'd like you to go ahead and try the example on the right here, which is y equals 3 times x minus 1 squared plus 8. We'll go over it in class. Okay, so let's convert from standard form to vertex form. We're going to look at the one on the left. The one on the right is for you to work on your own, and we'll go over it in class. Okay, so we have this equation, and we want to convert it to vertex form. Now remember, vertex form, we need to think about what we need. We need A, we need that number out in front. We need H, and we need K. So we need the equation for the vertex, the point for the vertex. All right, now we have a way of finding H comma K. And that is H is equal to negative B over 2A. Now that should sound fairly familiar to many of you, I hope. Okay, there's a reason. Okay, that's exactly your instinct is right. It does come from the quadratic formula. So A is 3, B is negative 6. So that means that negative B, which is negative 6, divided by 2 times 3, which is negative of negative, which is that makes it a positive, right? 6 divided by 6, which is 1. Okay, so the x coordinate is 1, which means if I plug that x coordinate back into the equation for y, I'm going to get the value for k. So that means that our vertex is at the point 1, comma 12. Okay, and I can now plug in to the vertex form and get my new equation. So 3 is still A. Okay, A is the same in both forms. It's the same exact number. And I have x minus the x value, the h value, which is 1, all squared plus k. So if I were to FOIL this out, I could get back to this. All right. Very nice. All right. So let's practice graphing from this vertex form. And this is the equation we had on the last page. Okay. Let's remember what we know about this. We know that first of all, it's facing down. This means it's facing down. 2 means I'm stretching it like taffy. Okay. It's getting longer or narrower. Okay. Remember, a half is the one that made it smushier. Okay. So longer and narrower. Okay. So it's going to be a little bit longer and narrower than usual. And the vertex will be at the point negative 1, comma 3. Okay? So we should be looking, if this were a multiple choice for instance, we would be looking and saying, which picture has a vertex at negative 1, comma 3, is facing downward, and is a little bit longer and narrower than usual? And this is the picture. There's negative 1, comma 3. That makes the axis of symmetry right here. So it looks the same on either side of that line. Okay? And notice that it's a little bit more narrow than the parabola that you see usually when you graph. Okay? So typically a parabola would go over and down, and that would be a point on the parabola. Over 2, down 4, that would be a point on the parabola. Over 3 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So typically, with a typical one that hadn't been stretched by this factor of 2, it would be going over 1, down 1. Over 2, down 4. Over 3, down 9. But now it's going over 1, down 2. That's the negative 2. Over 1, down 6. Okay? Over 1 down, so over another one, over 3 down 18. Okay? So that's what we're looking at here. Okay, finally, the book talks about another form, and I'll call this factored form. Okay, the book calls it intercept form. It's the same form. So the third form is a form that's more useful for things that other than graphing, although it can be very, very useful for graphing too. Okay. But we can use some of the information here to get an even better picture in your graph. So if we look at this graph right here, if we look at this function right here, this is a parabola. This is a quadratic function. If I FOIL these two terms out and multiply the 2 through, I'm going to get an equation in standard form. I could then use my knowledge about h to find the vertex form. That's not a bad question for an exam. Hint, hint. If I gave you a form like this, ask you to turn it into standard form, and then to turn it back into vertex form. Okay. So what does this mean, though? Well, what this is useful for, the reason they call this intercept form, is that I can figure out where it intersects the x-axis. It intersects the x-axis at -3 and 1. Oh, -3 comes from here, and 1 comes from here. Okay, so this comes from a very simple fact, and that is, if y equals 0, then this is my equation. And this is true of any polynomial function, not just quadratics. So if 2 times x minus 1 times x plus 3, if that product equals 0, think about your knowledge of 0. That means that either 2 equals 0, well, it doesn't, right, because 2 is 2. All right, so that's not true. Or it could be that x minus 1 equals 0. Or it could be that x plus 3 equals 0. Well, x minus 1 equals 0, if I add 1 to both sides, that means that x equals 1. And if x plus 3 equals 0, subtract 3 from both sides, that means x equals -3. Okay? So when you have an equation in what we call factored form or intercept form, okay, when you have an equation in factored or intercept form, the easiest thing you can do is to figure out where it hits the x-axis. Okay? And you can read it right off of the form. The parabola will hit the axis here and here. Now the thing about intercept form is it doesn't tell you anything else. You don't know if it's faced up or down. Well, you can find out from A. You don't know how wide it is. You don't know where the vertex is automatically. The thing that's easiest to read right off the bat is where does it hit the x-axis. Okay, well that's pretty cool, right? So the other thing we can find out pretty easily, oh, this is a little bit more work, is the axis of symmetry. Okay, and therefore we can find K. To figure out where the axis of symmetry is, there it is right there. Okay, we average this value and this value. Okay, because we figure that it's a perfectly symmetrical shape. So if it hits in this place and this place, the vertex must be halfway in between. So x is simply the average of -3 and 1, which, yeah, right, -1 is the axis of symmetry. This is a calculation I am not terribly concerned about your ability to do, but we may use it on a homework assignment here or there. This is not a topic that I'm terribly concerned about. I am concerned that you're able to read off where the intercepts on this graph are. We're going to be spending so much time dealing with intercept forms of parabolas and of quadratics and of other polynomial functions, it might make your head spin a little bit. Okay? So let's get comfortable with it now. All right, that's it for today, and I'll see you in class.